Not too long ago, bacteria were thought to be mainly planktonic, the sort of free-floating microbes you would find in a lab culture. A lot of antibiotics were developed to kill these individual bacteria. So were a lot of household germicides. Are they effective? Not anymore. Antibiotic resistance has become a global health emergency, and bacteria are proliferating everywhere, in, on, and around our bodies. Where did we go wrong? In the real world, bacteria don't always hang out as individuals. Most of them form communities for mutual benefit, the way humans do. They build biofilms. It all starts when individual bacteria release chemicals in a process called quorum sensing. It's basically a head count. When they sense that there's enough of them around, they start building a biofilm. A biofilm is a slimy matrix of complex sugar molecules, which glues the bacteria together to almost any surface. Once they're safely inside, they multiply rapidly because it's very difficult for anything to get in. Antibiotics, our immune system, or disinfectants. That's a huge problem. In hospitals, biofilms are one of the major causes of infections and death. And those infections spread because the biofilm eventually disperses bacteria to colonize new surfaces. So, how do we break the biofilm? Use the microbe's own tools against them. Bacteria produce enzymes that cut and shape sugar molecules to make their sticky matrix. Researchers are now deploying those exact same enzymes to chew up the sugar armor and expose the microbes to white blood cells and antibiotics. Here's another breakthrough. The biofilm is a working community where some cells supply food like the amino acid glutamate, others act as soldiers, still others expand the biofilm. How do they coordinate their activities? They communicate electrically. Hi! Bacterial cells contain a protein called an ion channel, which releases potassium ions. These positively charged ions are sent as electrical messages to other cells to start and stop dividing, among other things. What happens to the biofilm if you disrupt its communications network? Hello? 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 This new bioelectric bandage has silver and zinc dots that generate a tiny current on contact with bodily fluids. That's enough to send the biofilm's potassium ions haywire, disrupting communications and destroying the matrix. Enzyme technology and bioelectric bandages are just two of our weapons in our battle to break the biofilm. And the good news? More are on the way. My name is Mira, and I hope you found my presentation informative. Thanks for watching.